Hello children, welcome back again. In this particular video, we are going to learn about the continuation of bases, and that topic is called, here it is, alkali. What is that? Alkali. Remember the word alkali. A-L-K-A-L-I. Alkali. Okay. This alkali is having a special term in the base section. We have to learn and remember, particularly in further classes too. Okay. So what is an alkali? We'll see. So the base which is soluble in water is called as an alkali. Simple definition. Okay. What is alkali, children? A base which dissolves in water is called as, dissolves in the sense, soluble in the sense, కరిగిపోయి అది బేస్లో అంటే వాటర్లో ఆ బేస్ అనేది కరిగిపోతుంది, దాన్ని ఆల్కలీ అంటాం. ఓకే, వీ హ్యావ్ టూ కైండ్స్ ఆఫ్ థింగ్స్ చిల్డ్రన్, లిజన్ కేర్ఫుల్లీ. దిస్ ఇస్ రిగార్డింగ్ bases which are classified into two main things. That is, first is regarding soluble base and the next one is insoluble base. What's the second one? Insoluble base. In the sense, whatever bases which soluble in water are called as soluble base. Ante base anadi water lo karigipothe, dissolve aipothe, we call it as a soluble base. So dissolved in water, we can say dissolves in water is called as a soluble base. What is insoluble base? Water lo dissolve avvakapothe, that is a insoluble base. Okay, now which does not dissolve in water is called as insoluble base. Clear? Now the soluble bases are called as alkalis. Alkalis are also based on solution, but it is soluble in water. That's it. Now the definition of the alkali, I'm writing here, see carefully. The bases which soluble, okay, alkali, no, I'll write like this, wait. Yeah, alkali is a base which is soluble in water is called as alkali. That's it. Did you understand, children? Did you understand? Once again, see, alkali is also a base, but that which is dissolving in water is called as an alkali. So alkali is also a base term only, but which are soluble in or dissolving in water, those bases are considered as alkalis. Okay, a base which is soluble in water, okay, is called as alkali. A base which is soluble in water is called as alkali. In the sense, soluble means dissolve, karigipovodam. Okay, and one more for you. Okay, one more point to be noted here, it is there is a modern concept of alkali. I'll write the next slide. Yes, we have a modern concept of alkali. What is that? Let's see. There is a modern concept of alkali. What is that? Let's see. Okay, base is a base or else a compound, we'll write that like that, wait. Okay, a compound which on dissolving in water furnishes OH minus ions. What they are furnishing, children? Furnishing means giving out. Furnishes means giving out. Which ions they are giving out? OH minus. You can see the ions over here. So a compound which on dissolving in water furnishes OH minus ions as the only negative ions. Children, this is a negative ion or positive ion? This one, OH minus. Minus means negative, no? Plus means positive, right? So, which the compound dissolving in water gives out OH minus ions as the only negative ions is called as an alkali. Okay, this is a modern concept of alkali. Before one is a general, simple, basic definition. Okay, and a base which is soluble in water is called as alkali. But here, what is the concept behind that? A compound which on dissolving in water furnishes OH minus ions as the only negative ions is called as an alkali. Do you understand, children? Yes. There is a point to remember here. Let me write that point for you. I told you, no, alkali is considered as bases. Yes? Yeah. So here one point to be remembered. Children, they'll ask this kind of points in examinations. Okay? They'll ask in the assertion reason type also. Okay, we'll see what is that. I told you all alkalis which are soluble in, what is alkali? The soluble bases. Okay, so we can write as all alkalis are bases. What we can write, children? All alkalis are bases. But one more, but okay, all bases are not alkalis. Did you get that point, children? Very, very important point to be noted. You know why? They'll ask these kind of things in their examinations regarding assertions, reasons, statement wise questions. Okay, so what is the point to be remembered, children? All alkalis are bases, but all bases are not alkalis. Once again, repeat after me. All alkalis are bases, but all bases are not alkalis. Why, ma'am? Why it is so? We'll see. Children, see, I told you we have two kinds of the classifications regarding soluble and insoluble, right? So all soluble bases which are called as alkalis are coming under bases. Yes, but all bases may not be alkalis. Yes, they may be insoluble bases also. That's the reason I told you all alkalis are bases, but all bases are not alkalis, because there's one more classification, okay, of insoluble base. That's the reason I told you like that. Okay, so here we have to note the point regarding all alkalis are bases, but all bases are not alkalis. Very, very important point. They'll definitely confuse you regarding your statements wise questions. Okay, not, remember the word not. Okay, all alkalis are bases, but all bases are not alkalis. This is all about the alkali. What is an alkali? Once again, revise. Yeah, a base which is soluble in water is called as an alkali. Where the word alkali came from? Yes, bases are classified into two, soluble bases and insoluble bases, and those bases soluble in water, which means dissolving in water, is called as an alkali. Okay, there is no such name regarding insoluble base, children. Only soluble base we have the name, that is alkali. Okay, that is different. Fine. So alkali coming under soluble base. This is all about the alkali, simple definition. And modern concept of alkali is that a compound which on dissolving in water furnishes which ions? OH minus ions as the only negative ions is called as an alkali. Okay, so what is the point of remember? Yes, all alkalis are bases, but all bases are not alkalis. This is all about the concept alkali. Okay, children. Children, many of you will confuse regarding the words, two words. I'll write here. Alkali and alkaline. See, there is extra Ne over here. Remember that. Okay. Alkali means, what is alkali? What is alkali? Tell me, what is alkali? Alkali is nothing but soluble base. Okay. What is alkaline? What is alkaline? Suppose I told you alkaline solution. Okay. Acid and alkaline. What is that? Alkaline is nothing but the other name of base. Directly base. Okay. Fine. Clear, no? Alkali means soluble base. Alkaline means just a base. This is a base, that's it. if there is a reason regarding acid and alkaline, that is acid and base. Okay, alkaline solution, which means basic solution. Right here for you, wait. There should be no confusion regarding this. Okay, if they write acid and alkaline in some books, that means here alkali means nothing but base. Okay, if they write regarding like this, alkaline solution, so what is the meaning of that? Is nothing but it is a basic solution, that's it. Okay, alkaline word means it is a base. Okay, fine. But alkali means what is that? Alkali is a soluble base. Very good. Alkali is a soluble base. So these terms you have to remember in the mind and just go with the concept. Okay, don't ever confuse regarding these things. Okay, clear now children? Now I'll write some examples regarding the alkali. Examples of alkali. Okay, examples of alkali. Examples of alkali. Yes. So here we have examples regarding alkali. We all know in the discussed in the basis concept. That's the thing. Okay. We have alkali such as sodium oxide. Clear? So how this sodium oxide is reacted? You know how it is reacted with water. We know this is reacting upon which one? Water. Very good, because those are dissolving in water, no? Soluble bases, right? Alkalis. So here we have to add these things. Okay, fine children. Okay, so sodium oxide and water gives rise to, it is a irreversible, no? What is this? Only one arrow mark means reversible, double arrow mark means irreversible. Okay, this is a reversible reaction. So Na2O plus H2O gives rise to 2Na plus 2OH minus as the products. So when a metallic oxide react with what, it gives rise to Na plus 2OH minus. Simply children, this is the base soluble in water, gives rise to OH minus. Another definition. What's the definition over here? A compound which on dissolving in water furnishes OH minus ions, right? Okay, a compound, okay, dissolving in water furnishing OH minus ions, that is a alkali. Very good. Now one more definition, so one more example for you. Now K2O plus, yeah, water again, reaction. Yeah, it is irreversible, reversible reaction, right? So it is giving as 2K plus and 2OH minus ions. Okay. Now one more example, CaO. Try for this. Try these two examples on your own. CaO plus water, very good, gives rise to reversible reaction. Okay, 2 arrow marks. Fine. Now gives rise to come on, tell me. This is Ca plus 2 calcium, no? And 2 OH minus ions. Okay, what about magnesium, children? When magnesium oxide gives rise to, react with water gives rise to Mg plus 2 OH minus ions. These all are the examples regarding metallic oxides. What are all these, children? These all are metallic oxides. I don't know all metallic oxides, the simple oxides are bases. Yes, these all are metallic oxide. This is what about this H2O? Water. When these both react, they are furnishing all OH minus ions. Clear? Okay, including the ions. Fine. So whenever the compound which reacting with the dissolving in soluble in water gives rise to including plus and also minus, children. See, I told you there is a minus negative ions as the only furnishing OH minus ions. I told you, no, regarding alkali, that is it. Okay, a compound when dissolving in water furnishes OH minus ions as the only negative ions. Other one is positive, no, plus 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 plus. Okay, now minus 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 minus. So only OH minus ions are seen as the only negative ions in the particular reaction. So this is an example of the alkali. Examples of alkali. When a compound reacts in the sense dissolving in water, okay, gives rise to, it furnishes OH minus ions as the only negative ions is termed as a alkali. Clear now? Clear now? Yes, this is all about the examples of alkali, which is a metallic oxides. Now what about metallic hydroxides? We have no basis section, we have that also, no? We'll write for that also. Yes, one more for you. Okay, some more examples. Metallic hydroxides such as sodium hydroxide, potassium hydroxide. Okay, now calcium hydroxide, magnesium hydroxide. Try for these. Try for all these things, children. What we'll write? We'll write H2O, H2O, H2O and H2O. Now, what happens? It is a reversible reaction. Okay. Now, tell me, what are the products formed? All these are metallic. All these are metallic hydroxides. Very good. Metallic hydroxides. Okay. Clear. This is all about H2O means, yeah, water molecule formula. Okay. So, when metallic hydroxides, the compounds which on dissolving in water furnishes OH minus ions, also called as a alkali. Okay. So, what are things, what are the products we get over here? In the first case, first example, NaOH plus H2O, we get Na plus and OH minus. Second one, K plus plus OH minus ion. Now, third, CaOH twice. What is that? Ca plus 2 and OH minus ion. Now, fourth, MgOH twice. Mg plus 2 plus OH minus ion. Ma'am, why here plus 2 plus 2? Why here only plus and plus? Because the valency. Okay. We have here Na one element and OH one. Okay. Na a metal, OH hydroxide. So each one will get a plus, Na plus and one OH minus. That's it. Balanced. But here we have CaOH twice. So this twice goes with the crisscross method. We will learn in the particular periodic classification. There will get Ca plus 2 as the particular valency ion and OH minus. Okay. You got any doubt? Shall I explain you for that? You want that explanation? See children, NaOH na. So one Na and one OH. Okay. So whatever we have plus, we call it as cation. What is this? Wherever we see a positive ion, we call it as a cation. The negative ion is called as an anion. Okay. So ions are differentiated into two, cations and anions. Cations are positively charged ions, anions are negatively charged ions. So here we have Na plus OH minus. So after this crisscrossing, what we'll get? NaOH, that's it. So one here, one here. Clear? Now what about CaOH twice? CaOH twice. What happens, you know? This gives rise to Ca plus 2 OH minus. Or else, for you I'll write it more simply. I'll write it more simply for you. This Ca belongs to second group of the periodic table, children. That's the reason we have to keep your +2. Which is having OH is always -1 only. OH minus. Okay, minus. When these goes crisscross, we get Ca only 1 and OH we get 2. The formula will be CaOH twice. This gives rise to CHOH. This is a formula particular. The mixture, no? CaOH twice. We can write like this. Clear? So all these you learn in the further concept. Don't worry regarding that. That's the reason we have 2 and 2 here. Okay, children? These all are the particular cations which are only positively charged ions, and this is a anions as the only negatively charged ions. So wherever you find a particular compound dissolving in water gives rise to furnishing into a OH minus ions as the only negative particular ions is called as an alkali. Is called as an alkali. So these are the examples of alkali, right? Alkali. Clear? These are the examples of alkali in which category? Metallic hydroxides. Which category? Metallic hydroxides. So all these are reactions, examples of particular alkalis, children. So wherever you find, one more point, wherever you find regarding the reaction which single arrow mark, only one side, reactants and products, that is called as, once again, irreversible reaction. Irreversible reaction. So wherever you see reactants and products with double arrow mark, we'll write like this: 1, 2 lines, and with one half and with other half representation. That is called as reversible reaction. Reversible reaction. Okay. So reactants, after reactant give products, no, they can't be get back to the reactants. So those are named as which reactions? Irreversible reactions. So which we see whenever we see double arrow mark, reactants and products, double arrow mark, those are termed as reversible reactions, which means products can again coming back to the reactant states. Okay. In that cases, we will term it as reversible reactions. So all these are the reversible reactions. Examples of alkali and the concept of alkali is all for you in the particular video. Did you understand, children? This is all about the alkali here in this session. Thank you.